What is the maximum compression ratio of zip? What is the largest size of zip, say 10 kilobits for the sake of an example, can be decompressed to?
Update the 6th of February 2020. As mentioned in the comments, I have been unable to reproduce the original result with zip. Working on the assumption that I accidentally used a different compression format in that original quick test, I've repeated with zip and updated the figures below accordingly. This new result agrees with the theoretical maximum compression stated in other answers/comments. It very much depends on the data being compressed. A quick test with a 1 GB file full of zeros using a standard version of zip, with default options or specifying -9, gives a compressed size of 1018 kilobits, so your 10 kilobits file could potentially expand into 10 bytes. If the data has low redundancy to start with, for instance, the archive contains images files in a format that is compressed natively, GIF, JPG, PNG, then zip may add not further compression at all. For binary files like program executables, you might see up to 2:1 compression. For plain text, HTML or other markups, 3:1 or 4:1 or more is not unlikely. You might see 10:1 in some cases, but the 1030:1 seen with a file filled with a single symbol is something you are not going to see outside similarly artificial circumstances. You can check how much data would result from unpacking a zip file, without actually writing its uncompressed content to disk, with unzipcfile.gs, dubc bytes. This will uncompress the file but not store the results, instead passing them to dubc, which will count the number of bytes as they pass, then discard them. If compressed content is a tar file containing many small files, you might find that noticeably more disk space is required to unpack the full archive, but in most circumstances, the count returned from piping unzip output through dubc is going to be as accurate as you need.
Quoted verbatim from this URL. The maximum compression ratio of the deflate format is 1032:1. This is because the longest run that can be encoded is 258 bytes. At least 2 bits are required for each such run, 1 bit for the length code and 1 bit for the distance code. Hence 4 times 258 equals 1032 uncompressed bytes can be encoded per 1 compressed byte. You can get more compression by zipping the result of zip. Normally that doesn't improve compression, but for very long runs it can. By the way, the LZ77 approach used by deflate is more general than run length encoding. Instead of just a length/distance pair is used. This allows copying a string from some distance back, or replicating a byte as in run length for a distance of 1, or replicating triples of bytes with a distance of 3, etc.
Usually you don't get more than 95% compression, so that 10 kilobits zip data would decompress to 200 kilobits, but there are specially crafted files that expand exponentially. Look for 42.zip, it decompresses to few petabytes of meaningless data.
The compression ratio of any compression algorithm will be a function of the data being compressed, besides the length of that data. Here is an analysis at maximum compression. Look at one of the samples like Summary of the multiple file compression benchmark tests.
If you want to support the channel, please consider subscribing.